All right. Let's log in. Day 88, I believe. Delete code because I have a stats quiz to study for, then I'm dead ass failing. I gotta log in. So 87, 88. My goal for before the summer is to hit 300. So let's get to it. Let's do this one. Like, I'm so bad at stats. I need to study this. So in the project, I'm so cooked with the project. I need to really I wish I had one day just to myself, but lately I've been so busy. So leak was the easiest thing I can do to make myself feel productive, you know. This was so easy too, man. Next DP problem, I feel like I could do it. Like, this formula was like pretty intuitive, but I don't know. Majority element. Let's see it. Given an integer array of size n, find all elements that appear more than n divided by 3 times. Okay. What does that mean? Okay, so let me see. Let's calculate this. That's 3 divided, so at least 1? More than. Okay, so it has to be 2 or more. Okay. 1 divided by 3. Rounded down, I assume. Majority element. Wait, let me pull up the calculator. So like, if 1 divided by 3 is rounded down, so it's more than 0. Okay, I want to be, I guess, kind of greedy here. I don't want to pick the most. Wait, fine. Could this be more? Oh, okay. Now, see, you could put, it could be more than, you know. Let me see. That's 2 divided by 3. 2 divided by 3. Rounded down is 0. So what appears more than 0 times? This is pretty easy, but now the follow-up is this. I'll do that after. Let me just do the naive solution, or I might. So let's do this. No, I'm gonna write everything out. I'm not gonna be a Python kitty, Pythonista, as my professor says, Pythonista. Okay, find all the elements that appear more than that times. Okay, whatever. Yeah. I don't know what to call this. Let's call this thing called let's call it K, because it's kind of a common thing in code. Or well, I've gotten the frequency, and I wanna. Okay, yeah, and then I guess res here, right? For every num in freak items, right? Res the append n if f greater than k. Oh my lord, no, 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 no. Whoa, what was that? Give me back to my... Okay. Oops. That should work, right? Does it have to be in a specific order? I'm not sure. We'll see. Because it's kind of undeterministic, but... Okay, that's way too easy. Now let's try to do the follow-up, right? With constant space, right? With linear time and constant space. That is the hardest part about this. I know there was like a Cadane's algorithm, right? Cadane's algorithm. Or is it Cadane's voting algorithm? Okay, never mind. It's fucking Boyer-Moore majority voting algorithm, right? There's this voting algorithm that like as you go through it, it keeps the most frequent count ever, you know. Now my problem with that is I do need to alter it to solve these problem, right? Right. Like what? Okay, what does it say? Think of... fucking Miller. Oh my god, the Boyer-Moore voting algorithm, which is finding elements appear more than a certain threshold. It's not Cadane, that's the sliding window one. It's Boyer-Moore majority voting algorithm. I'm processing an element X if the counter is 0, X to the stored element, and either increments the counter if they're equal. Initialize element M and a counter C with C equals 0. If C equals 0, then assign the what if I do... what if I make however, it is possible to perform a second pass over the same input sequence in order to count the number of times the report occurs and determine whether it is an actual majority. The second pass is needed as is not possible for a sublinear space algorithm to determine whether the Okay, I kind of see the Boyer's voting algorithm. Let's try to so this will give me the most frequent one. But I need to adjust it so that it appears more than this time, right? Well, we'll have this length of nums, right? We have the CNT, and then we have the element most for every n in nums, if oh my god, n frequent, most frequent is equal to n, then elif wait if how do I adjust it so that it can be more of a list? This is just finding the most frequent element. I don't know. How would you do this, right? If this is this, that means okay. I'm gonna do this. Res equals this. Res dot append n, or the previous one, right? No. This is fine. This is that. If CNT greater than k at any point, we can just Oh wait, not break, just continue, right? Interesting. Maybe I should put the I'm feeling I have close here. You know what I'm saying? I feel like I'm close, guys. Like, I know I know it's Cadane's algorithm. Let me just do something really quick. Let me just implement Cadane's algorithm correctly. Right. Fuck. Oh lord. Oh. Let's do like one. Oh my god. This one. Okay, so I'm doing this right, I think. Right? Still should be. Let's do. What should. Is it gonna be 2? Still 1? Oh yeah, that makes sense. Wait, no, it should be. Wait, I did this wrong then. Oh wait, I never decrement anywhere. Okay, I'm gonna do these. If m freak I say that should be kind of the gist. 23. No, that's wrong. It should be 22. Or it just should be 2. So I'm doing this wrong. Let me see. Yep. For each element of the input, if c equals 0, then assign the m. I'm gonna call this m. M freak m. Else if m equals x, then yeah. Else. Okay, this is the algorithm. What? How am I doing this wrong? Okay, I think I have an idea. Maybe it's because that's ridiculous. Wait, am I comparing the most frequent with the element? Yes. Maybe I should do this. There you go. And what happens if they're all equal? Just take the first element. Okay. Very nice. Then. At any peak, right? If any peak, at any peak, if it's greater than here, we want to put, we want to put the that thing there, right? Makes sense. It should be all of them, so I got this wrong still. Oh, why did it duplicate? Oh, okay, wait. I see now. No. Damn, I don't know. Whoa. I see the issue now. It duplicates, like, if the most, it's gonna like trigger that all the time, so. Maybe I'll do it here. Since, because this is it fell down, you know? So, we'll see. I swear I have to be doing this right. Doing this wrong. Come on, I know I have to use this. Let's draw it out. Let's try this out. 1 second. Like, okay, if I have the Cadane's algorithm right, I should get 2, but let's say, what is this? 1, 2, 3, 4, 5, 6, 7. What is that? That is 3.3. I need any elements that have a frequency greater than 3. So, so it should be 2. Just 2, actually. Actually, I want to make this more interesting, so maybe I could do Cadane's algorithm twice. Wait, I know the hint said it can be at most 2. I don't know, whatever that reason is, right? I find the most frequent one, then the second frequent one. For example, Wait, is that really true? Why? The most was 2. This was just 1. No. So let's see. Damn, it's hot. Okay. I'm gonna add a one more 1 for the sake of this example. So let's do x. It's 8 divided by 3. Round that down, that's 2. So I need something that's greater than 2. So 1 should be there. 3 should be there. No, not 3. 3 and 4 should not be there. 2 for sure. So the result should be 1 and 2. But how do I get that with the Boyer's algorithm, right? So I'll go through here. 1's the first. C and T equals 1. Go here. That's gonna be increment to 2. Go here. That's decrements. Go right back to 1. Back to 0. So we're here. So we go here. And 1. Then that goes back down. So yep. That's the 0. Next check. 2 is gonna be the most frequent one. Oh god. Oh my god, no. 2 is gonna be the most frequent one. And we're back to 1. Increment that to 2, down to 1. Back to 1. Yep. And we'll return this. And that is the most frequent one, you know? But what if I adjust it so if the count ever equals k, the k was to be at least 2. This is the requirement to be, right? Man, I'm stuck. I don't know. How could I do this constant space? Like I have the k right here, right? Okay, so go through here, 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 go through. I go through here, I go through here, I enter this, I enter this. I don't know. Like, what if it's okay? If at its peak, what if I do a check right here? Brother, I'm cooked. 4 divided by 3 should be like 4 divided by 3. 4 divided by 3 rounded down should be 1. So it should be just 1 actually. So, or actually instead of this, I'm gonna say equals. Because it's like a, yeah. I'll try this. Doesn't work. Take the L. It's cooked. Maybe I don't need to put this. That sucks. Why? Find 2 majority candidates first. But that's... No. That's not good. I already did that. How do you do constant space? That's my intuition. It says that it can be at most 2. So I'll do M1 here, M2 here, and when we do the swap off, yeah, that, and then return M1 M. That's the thing. I never noticed that it did that. So, oops. Get rid of that. Close. Interesting. Oh. Just find 2 of them. Oh. Interesting. Okay. I see the thing. So we do twice. Right? We do it twice. So M1 here, M2 here. For every n in nums. If n equals m1, then cnt1 elif m equals m1 cnt plus oops cnt wait, these are the two most. If any of them are 1, then just basically do it twice. Okay, so elif cnt1 equals 0, then n equals, or m1 equals n, and cnt1 equals 1. Else now we go through for every n in nums again. If n equals, okay, no, I guess I have to count again. Counter 1. It's just verifying it again. Okay. If n equals m1, if counter 1 greater than k, where's the pen? M1. I need to figure out why it's only 2 at most. Rather, I missed the Kanti. Oh, he actually increments it. You don't reset it. Interesting. I guess that's the same though. Maybe not. Well, yeah, if it's this, then yeah, it's gonna be the same. Bro, that was a very small thing. Anyways, that works. Anyways, thanks for watching. I'll see you for tomorrow's video. Peace.